In 1916, Gilbert Lewis defined a covalent bond as the result of two atoms sharing a pair of electrons. Atoms bond together to form molecules because the resultant compound is more stable and lower in energy than the separate atom. I want to emphasize this again. Again, you're forming a bond because the resultant compound is more stable. This is very important, and that stability comes from being lower in energy. This is going to be a theme throughout organic chemistry. The electrons of individual atoms are able to move in a way to minimize the repulsive forces. So you're minimizing repulsion. Of the electrons, and you maximize the attractive force to the nucleus. Right? And this is going to give you the internuclear distance where these forces are optimized, and that's going to correspond to the bond length. So again, the bond length is the optimum internuclear distance. This is where electron repulsion is minimized and the attractive forces of the electrons to the individual nuclei are maximized. The energy that is released upon bond formation and that must be put into a system to break a chemical bond is the bond strength or bond energy. So again, the two components of a covalent bond are the bond energy and the bond length. And both of these result in a lower energy, more stable compound when they are optimized. So this figure takes those two concepts and ties them together. So here you can see energy on the y-axis and then you have the distance between atoms on the x-axis, or the bond length. The bond length observed is going You can think of chemical bonds or covalent bonds similar to a spring. When you compress the spring, it raises the energy. When you stretch the spring, it also raises the energy. But there's an optimum position where that energy is minimized. Here I have a carbon-carbon single bond, a double bond, and a triple bond. There are two things that we need to note. A triple bond is the shortest, and a single bond is the longest. A triple bond is the strongest, and a single bond is the weakest. In a triple bond, the nuclei, because the two atoms are closer together, they have a greater pull on the electrons between the two carbon atoms. And therefore, from this greater pull, you have a stronger bond and a shorter bond. So remember, a triple bond is the shortest and the strongest, and a carbon-carbon single bond is the longest and the weakest. Before we end this video, let's do problem 1.6 from your text. It corresponds to the energy diagram shown in solved problem 1.5. The question asks, which of the two curves in this graph represents a longer bond? So here, if you look at the two curves, we need to look at this bond length or internuclear distance. Okay. So you can see the red curve has a longer bond length because you are further to the right along the x-axis.